In this video, we will integrate a function of two variables over a region which is non-rectangular. So here we're integrating a function, but the region D here is not a rectangle. It's the region which is bounded on the left and right by x equals 0. So that's the y-axis, and x equals 2. So let's maybe draw it like this. Here's x equals 2. It's this vertical line. And below and above by y equals 0, that's the x-axis. And y equals 4x squared. So that's a parabola. So this is the region that we're looking at. It's underneath this parabola, above the x-axis, and bounded on the right by x equals 2. So this is our region of integration. So unlike in the case with a rectangle, we can't just integrate in any order we like necessarily. We have to be careful about how we're describing the region. So the way it's presented to us, we have to integrate y first and x second. The reason is that the x bounds are both given by constants, whereas the y bounds are not. The upper boundary in the y direction is not a constant, it's a function of x. So that means we have to do that integral first. So 0 to 4x squared. So we have to integrate y first and x second. So this is true in general. If we describe our region by inequalities like this, whichever direction is bounded by constants, in this case x, must go on the outside and be done last. And the other variable, if the boundaries are a function of the other variable, that one should be done first. Okay. But the process is the same. So let's go ahead. If we integrate y first, the 1 over x to the 5th plus 6 is just a constant. Right? We're pretending x is a constant here. So it's just like we're integrating the function y. So we just get 1/2 y squared. So again, this is just a constant that comes out when we integrate. And we just get 1/2 y squared from 0 to 4x squared. So if we plug in 0, it's just 0. If we plug in 4x squared, we get 16x to the 4th. And let's go ahead and cancel the constants. 16 over 2 is 8. So we'll simplify this to just 8. And pull that outside the integral. And now we can finish this up with a u substitution. So let's do u is the denominator. So du is 5x to the 4th dx. So we have x to the 4th dx, but not the 5. So we need to divide by 5 out here. And we just get 1 over u du. And what are the new bounds? When x equals 0, u equals 6. And when x equals 2, u is 2 to the 5th. That's 32 plus 6, so 38. So the antiderivative of 1 over u is just logarithm of u from 6 to 38. So we get 8/5 log 38 minus log 6. And this is fine, we could leave it like this, but we could also simplify it a little bit, because we know by logarithm rules that log of a minus b, or sorry, log of a minus log of b is log of a over b. So this is the same as the logarithm of 38 over 6. And that fraction can be reduced. 38 over 6 is the same thing as 19 over 3. So either of these two answers is fine, whether or not you want to simplify it.